Hey Vince, how are you?
Hey Bryant, sorry, I've
Y-
been
Uh-huh.
up since 6 and I just completely lost track of time.
Yeah, it's all right,
It's,
no worries. You woke up at 6 to study for OChem or what else did you do?
just all different assignments
Different
and
assignments,
yeah,
yeah.
and personal stuff too.
Personal stuff too, I see.
Yeah,
And what year are you in Canada College?
I'm a sophomore.
Sophomore? Okay, okay. I see. It's good. So how are you feeling about the class so far? Organic chemistry?
Um, Rough. It's pretty rough for me.
Pretty
Uh,
rough. Yeah. It is a
yeah.
hard class. It is tough. Um, and I saw the syllabus that you sent as well. And so, like, I saw what you wanted to go over, which is nomenclature of alkanes, alkane constitution isomers and their relative stability, Newton projections, acyclic alkanes, acyclohexane. Um, so what we could do is like you could send me the lecture notes of your class so that I could go over it, and that way I could teach you the way that your professor wants you to know it, or we could just go over a brief overview of these topics, and do some practice problems with that. How are you
Okay, I
feeling?
actually have a worksheet
Yeah, that would be
I
the best.
I'm gonna
Yeah.
send I want to send over to you. I actually have to do it as extra credit for today.
Mm-hmm.
So I thought
Yeah.
it'd be like a really good thing because I think it really covers all the stuff.
Mm-hmm.
Um,
Yeah. That's good. That's good.
yeah, thought
Yeah.
I'd just send that over.
Yeah. You can send it over and then we can work through that in this session.
Okay.
Yeah. When is your first exam?
I already had
Oh, you
my
had your first exam? Yeah, I see. I see.
yeah.
That's good.
I do have a quiz on everything I sent you for
Mm-hmm.
tomorrow though.
Oh, in-person quiz or is it online quiz?
It's an in-person multiple choice quiz.
In-person multiple choice quiz. Okay, okay. That's good. So hopefully when we go over the worksheet, that'll help you prep for that quiz.
Yeah,
Yeah. Let's
just
see.
trying to find it
Mm-hmm.
real quick.
Yeah. Are you around Canada College or do you commute there?
It's like an hour commute.
Oh, an hour commute.
Yeah, it's not fun.
Yeah, yeah. Especially coming back with traffic.
I have a printout. I'm just gonna take pictures and send it to you if
Mhm.
that's okay.
Yeah, that's okay. You could send pictures, send it to me, um, and then we'll go over it. Okay, got this one. Okay, I got the first one. Let me see this one. Draw a wedge dash draw. Just draw the lowest energy come from which of the following circular cases most angle strain defines the isomers. Okay, label each pair. Oh, okay. So the stereochemistry stuff on the worksheet was not part of the list that you sent, but we could still go over that if you would like to, like the
Okay.
stereochemistry part. Okay.
Um, yeah, really, if
Mm-hmm.
I guess if there'd be just something I want to focus on, the worksheet would be my number one, if that's
Okay.
okay with you.
Yeah, yeah. We
Um,
could do the worksheet like for your number one priority to today.
yeah,
Yeah. Okay.
appreciate it.
Mm-hmm. So number one, name the following compound. And let me actually airdrop this to my iPad so then I could like annotate on it so I don't have to like waste time writing all that out.
Yeah.
Uh, Let me see here. AirDrop. Oh shoot. It's trying to AirDrop to my laptop. Mm, let's see. This one. Hello. Um, okay, hopefully it works. Okay, there you go. Airdrop failed. Why? Let's try again. Okay, there we go. Let me airdrop all of these photos. Save, save, save. Airdrop this one. Okay. Okay. So for nomenclature of alkanes, there's a general guideline to it. The very first thing that I like to think about is locating the longest chain of the molecule, right? So
Yeah.
this molecule right here is right now in a Kikuli structure, right? Which is not very easy to read for me, in my
Yeah.
opinion.
Yeah.
Um, are you familiar with bond line structure?
Yes.
With
I'm
the,
not too bad
uh-huh,
with the naming of the following compound
uh-huh.
that much. Yeah.
Right, right, okay. So what I would do first is I would convert this entire structure into bond line structure.
Okay.
So this is a CH3 at the end right here. So we know that that's the end of the molecule. And are you familiar with reading bond line structures? Like let's say if I were to give you a random structure like um, this right here, are you able to understand what that means like that?
Uh, yeah, I could
Hmm.
find the name, um,
Right.
find the
Hmm.
parent, and then find the substituent.
Hmm.
Um, I don't have the names memorized. I have them down.
Right, right. Um,
Um, but after I find the name, I
you would be
like.
able
Do you want
to,
me to do this one right now?
yeah, yeah, do this
Okay.
right now. What's your thought
Yeah.
process for this one right now?
Okay. Um,
What is the longest chain here that you see?
so the longest chain is the bottom one,
Correct. This one right here. So that is 4 carbons long. Will it
which
go
is a
from left to right, like 1, 2, 3, 4 this way in this direction, or would it go 1, 2, 3, 4 from right to left in this direction?
we
The
number
direction.
it.
Oh, Vince, I think you cut off. Oh, hello? Hello?
Hello.
Oh,
Yeah.
okay. Yeah, you came back. Okay.
Okay.
Did you say you number it from left to right or right to
I
left?
the first one you did, yeah,
The first
from
one. Right. Left
because
to
the
right.
second number is
Mm-hmm.
well, the shorter side is closer to the
Mm-hmm.
substituent.
Correct. We want the first substituent to be the lowest number possible,
Yeah,
which is number two if we go this direction. If we were to go this direction, it would be number three, which is higher, and we don't want that.
yeah.
And because this is our parent functional group right here, the parent chain, right? 4 carbons long. Do you remember what the parent name would be? Like if it's 4 carbons long?
Yeah, it's butane.
Butane, correct. Butane. And if we have this substituent on carbon two, what is the substituent on carbon two first?
It's 2-methyl.
Methyl, correct. So it's gonna be two dash. We put dashes between letters and numbers. Methyl butane. So that's the name of that structure right there,
Yeah.
right? Okay. So now let's just convert this Kikuli structure into bond length structure so it's easier to read. The CH3 is right there. This is gonna be the Br, CH2, and carbon. Are you familiar with how to do this, or do you want me to walk you through on how I'm converting this structure here?
If you could walk me through
Hmm.
converting it, maybe
Right.
that'd be
Okay.
helpful.
Yep. Okay. So let's do that. So each point here represents a carbon. So this is a
Yeah,
carbon. This is a carbon. This is a carbon. This is a carbon. This is a carbon. And each carbon, if it's neutral, how many bonds would the carbon have if it's neutral?
it's gonna have 4 bonds.
Four bonds, correct. So if we have this one carbon right here that's neutral, we only see one bond attached to it,
Yeah,
meaning that it will have three invisible hydrogens. There's three invisible hydrogens right here that are implied. How many hydrogens would this carbon have right here?
that would have two.
Right. How about this carbon here?
One.
One. That's right. So that is probably the trickiest part, right? So
Yeah,
this H3C right here is this H3C right here. That carbon there with three hydrogens is this part of the structure right there. But
yeah,
right, these three hydrogens are just invisible. And then
yep,
this next carbon right here that I drew out is this carbon right here
yeah,
that's directly attached to this bromine. And it's attached to one hydrogen, right? And we see that it is attached to one hydrogen right there, right? And if we
yep.
move on to the next carbon, which has two hydrogens. So that's how I know to keep going, because if I added another carbon there, this carbon here would have only one hydrogen. But because we see that this carbon has two hydrogens, I only extended it by one carbon to give it two hydrogens, right? So now I'll have you try. What do you think this carbon here is going to be attached to if that carbon is this carbon right here?
It's gonna be attached to a CH3.
CH3. And how many CH3s do you see attached to that C?
There's two
Two.
CH3s.
Correct. So I would draw out the two CH3s coming out this way, one there and another one there, right?
Okay.
And that means the next carbon is going to be this carbon right here. Now, what is going to be attached to that carbon there?
Um, H2.
H2?
So
Correct.
yeah,
And we don't have to directly draw it out because it's going to be implied. It's going to be invisible.
yeah.
So you would then extend it, which is going to be this carbon. And what would this carbon be attached to?
It's attached to a CH2 and a C.
So this
Or is
carbon
it?
here
Yeah.
has no CH2. It only has one H, right?
Oh
So
yeah.
that means that this structure here is a substituent, which we can draw out like this. So we know since it only has one H, um, we're gonna extend it by two other carbons, and I'm drawing a squiggly line to show that I don't know what that is yet. It's a fragment,
Okay.
right? But we know that that's gonna be the case because this carbon here, which is this carbon, only has one hydrogen, which is this one invisible hydrogen right there, right?
Gotcha.
Now let's focus on this substituent right here. This substituent is gonna be, let's look at this carbon here. This carbon here is gonna be this carbon. What is that carbon attached to?
Three CH3s.
Yes, three CH3s, which we could draw out like this. One, two, three. Like that,
Gotcha.
right? Now, this carbon here that we just drew out is going to be this carbon right here. Now we're almost finished here. What else do we have to do to finish off this molecule?
We have to draw in the CH2 and the CH3.
And the CH2, like the C is already drawn out for us. Like when I drew out the extension, like this C here is that C right there.
Yeah.
And the H2, we could be implying that, and we don't have to draw that out. So then we could just draw out a CH3 coming out like that, where this is the CH3, and this is the bond line structure of this right here.
Gotcha.
Right. Okay. Now that was probably like one of the difficult steps. Now the next step is determining the longest chain, right? So how would you go about doing that? Like where would you start your number one carbon? Like you could either start from here, here, or here.
Um,
Mhm. And then
Yeah.
you could try. Let's try. Let's try going here. One, two, three, four, five, six. If we go here, right? Seven, eight. That's seven, eight, seven, eight. Oh yeah, that is gonna be the longest chain. Um, because I was gonna say that you could also go here, seven, eight. So there's two routes that you could go like that. Or you could start from here, saying this is one, two, three, four, five, six, seven, eight. So that's also eight. Okay, okay. So all of this, right, is gonna be eight, like one, two, three, four, five, six, seven, eight, six, seven, eight. So now because they're all the same, we're gonna have to look for the one that has the substituent on the lowest number, like we said earlier, like you said earlier.
Yeah.
Okay. So let's see here. Where do you think that's gonna be? Where do you think our lowest substituent is gonna be at?
It's either gonna be the first, like on the left side, or the top right corner.
One, two. Right. Uh-huh. So if we go on the left, the first substituent is bromine, which is on carbon two. But that's only one substituent. If we go on
Yeah.
the top right corner on carbon two, there's two substituents.
So go with the one on the top right.
Yeah, go on the one on the top right because we want the most substituents on the lowest number possible.
Yeah.
Right. Okay. So that's why I'm gonna number it like this, where this is one, this is two, this is three, four, five, six, seven, eight. And I'm just gonna highlight the longest chain just to show that that's the gonna be the parent name. And then I'm gonna circle the substituents. These are the substituents right here.
Yeah.
Okay. Okay. Now, can you tell me the names of these substituents for each carbon? Or like how many unique substituents do you see?
You froze a bit. Did you say
Oh,
anything?
yeah. So what is the parent name if our longest chain is 8 carbons long? Like
Our
what?
it's
Oh shoot.